Thank you everyone for joining us today for this final internship talk by Margarita Geleta. She joined us from UC Berkeley for the summer, and she worked on an exciting topic, which is speech live translation. One small disclaimer, there will be some audio examples in this presentation. If you're listening remotely and you're wearing headphones, you might be able to hear those in stereo, so you can appreciate left and right. If you're in a room right now, you probably won't. So with that, all yours.
Thank you, Hannes, for the kind introduction. I want to thank my mentors for mentoring this during this internship, and today I'm super excited to present our 3-month research project titled Spatial Audio Rendering for Speech Live Translation in Teleconferencing. So before starting with the contents of the research project, I would like to give a brief motivation why this matter is important. Let's start with the fact that global teams are the engines behind humanity's most ambitious projects. Just to give a few examples, the Human Genome Project, which spans thousands of researchers across 20 institutes in 6 countries, which definitely sparked multilingual conversations along the way. The International Space Station Project, also so many organizations, 15 nations and 5 space agencies. And another big example is the Collider, the CERN Collider, more than 10,000 scientists and engineers from more than 100 countries. And that sounds great, but the issue with global teams are language barriers, the Babel Tower problem, where we can't really fully understand what is the message across. And one option is to use live interpreters or machine translation, which is more available to us. But we all know, because we all tried it sometime, and sometimes we get lost in translation. Here's a funny example. Translation from Spanish to English, no gritar means do not shout, do not scream, but the English translation is do not cry, because cry can mean screaming in some context, but that's more like crying as weeping. So we know that this can go wrong. So the standard in global communications is adopting a lingua franca, which is a language that is adopted as a common language between speakers whose native languages are different. And there are several lingua francas all over the world. Right now, right here, we're using English. And this requires non-native speakers to adopt a new language. And this, of course, can limit inclusivity and effectiveness in explaining, getting our message across. And in fact, there is research that even among the proficient second language speakers, there are still gaps in comprehension. So in current live translation tools, which do exist, by the way, some of the issues, besides getting lost in translation, are others. For example, when we synthesize speech, it can sound as disembodied, that it doesn't belong to anyone in the room. You can call it like robotic artificial voice. And once this happens, we can get other consecutive issues like speaker identity loss. We lose track of who's talking, and other factors that we can't really control, such as the lag between the translation and the original speech, which has this established fixed gap between different languages. I will talk about this more later, but just to give you a brief spoiler, every language has a different grammar structure and word order. So English is subject, verb, object, but some languages are different. They use subject first, then object, and then verb at the end. And if we're trying to translate a subject, object, verb into subject, verb, object, we need to listen to till the end, grasp the verb, and then we can start translating. So there are some issues that we can't really control fully. But what are the variables that we can actually control? And how should we manipulate them in the optimal way to deliver the best experience in live translation? So that's the idea behind this project. And in parallel to all this global team translation conversation, there's also the fact that teleconferencing is becoming our new office, especially after 2020 when everyone started working remotely and then hybrid work became the standard. Platforms that have live translation or will provide live translation, they are the lifelines for hybrid work. And existing research already has proved that spatial audio is helping delivering the conversations and efficiency in same language calls. But to the best of our knowledge, multilingual meetings is a blind spot in design research regarding spatialization of audio. So specifically, our project revolves around analyzing what is the effect of spatially rendered translated speech in teleconferencing scenarios. And from here, we define our two research questions. The first is, does spatial audio improve the effectiveness of live translation in terms of comprehension of the conversation, cognitive load, and satisfaction, how easy it was to understand, how immersive we feel in the conversation? And the second research question is whether spatial cues help better tracking the conversation dynamics, that is, following the turn-taking, identifying who's the speaker and what is their role. And from these two research questions, we define our four hypotheses. So the first is we want to test whether spatial audio improves comprehension of the meeting. Second hypothesis, we want to see if spatial audio lowers the cognitive load. Third is whether spatial audio increases the satisfaction, as I mentioned, easy, clear, immersive. And finally, more related to the second research question, does spatial audio improve speaker attribution? Can we map out who is talking at each moment in the conversation spatially? So the study idea is to simulate conversations, meetings where we have a multilingual scenario. We would have two speakers who are speaking between them in a native language, and we overlay a live translation in English. The issue is that if we use an existing live translation tool, we don't control several variables that we would like to control in order to isolate the effects of the audio condition. So we want to control the delay. We want to control the timbre of the translator, their voice. We want to keep it the same. And we also want to control the quality and the accuracy of the translation. Since we had to control all those variables, we opted to use what is called a Wizard of Oz simulation, where we, as experimenters, we control the output. So in this case, we didn't use any live translation tool. What we did is we simulated a live translation tool by recording both the English translation and the original speech, and we manually overlaid this and then delivered this stitched audio channels to our participants. And in their mind, that would look like a live translated session, and we would never disclose it was manually done. So in order to do this, we split our user study in two phases. The first phase involved in creating all those Wizard of Oz live translated sessions, including things that we will go over right now, how we selected the languages, how we made the scripts, how we recruited the bilingual confederates, how we developed the stimuli, how we processed the audio, how we spatialized those samples, and how we randomized all those conditions in order to avoid biases in the results. And the second phase is the actual experiment, where we recruited our listeners, we collected all their data, all the measures, analyzed the results, and synthesized the design lessons and best practices for a live translation. So let's start with phase one, how we selected the language. Since we are using English as our translated speech language, we wanted to use some languages that are very different from English, that in order that the translation is genuinely needed in order to understand the conversation. And the selection criteria that we used included the language family, word order structure, what I mentioned before about subject, verb, object versus subject, object, verb, a different alphabet script, which is correlates with the language family, and then a few extras like resource availability and additional morphological complexities in the language that can also make the language more different from English. To give you a summary, we used 4 languages: Greek, Kannada, Mandarin Chinese, and Ukrainian. As you can see, their families are all different from Germanic, which is the English family, language family. Word order, English is subject, verb, object. The only one that is different is Kannada. So that's why you'll see that in Kannada, the delay is a bit longer than in all the others because we had to keep track of the verb. The script is also different in all of those languages. Resource availability is not directly relevant to the translation, but it would help with recruitment. Since 3 of the languages from our study pool had a low resource availability, it was easier to find pairs, bilingual speakers that would not speak 2 pairs of those languages. And finally, other characteristics. Every single language has their own particularities. Greek is very expressive with nonverbal cues. Ukrainian has a lot of morphological structure. It's highly inflected, and other things. Once we selected the languages, we had to design the scripts or scenarios for our simulations, and we had to mirror real-world workplace scenarios for global teams. So we clustered them in those 4 groups. So the first one is talking about someone else, another person. For example, we have a hiring discussion, or we're hosting a visitor and we want to see what arrangements we can do for that person. The second one is more organizational, planning a team building event, planning a lunch outing. Third one is technically the most professional one. It's more about updates at work, a project update, or an update on presenting some slides to a team. And finally, the 4th one is also more work-related, about clarifications in tasks, and the delayed task is also a task-related conversation. So as you can see, they are all work-related. And they are all similar in complexity, and they are all 1 minute long. So here you can see an extract, how this dialogue looks like. We have speaker 1, speaker 2, and they have some interactions, 1 minute long. And after we finish the script, the participants, they would respond to a quiz. So we also prepared quiz questions for each script. And each quiz had 4 questions, each one trying to ask about a different thing from the conversation. So first is the temporal detail question, when something happened from the conversation. For example, when is Priya's interview scheduled? And that was mentioned in the conversation. So we want to see if the person has a factual recall. The second question is about action or theme. What is happening in the conversation? What is the gist of the dialogue? The third question is about role or identity, which is asking who did something in the conversation as a name or a team. And finally, the 4th is also about who, dialogue attribution, but it's not about the name, but more about the position on the screen. Is it the speaker on the right or the speaker on the left who said that? And once we defined all our scripts and the languages, we started with the recruiting. We recruited 8 bilingual speakers, 2 pairs, 2 pairs same gender, male, female, female, and 2 genders 2 pairs mixed gender, male and female. 4 scripts from the ones I showed you were read by same gender, and the other 4 by mixed gender. And before starting with the recording, we made sure that our confederates, since they are native speakers, they read the script and they checked that it's coherent and sounds natural. Here's an example how an English translation looks like, and then we have the same exact text in Kannada and the same exact text in Chinese. And the same would happen with Greek and Ukrainian. The actual recording happened in a recording booth that was had acoustical isolation. And this is the setup how our confederates would speak. Their faces, they would not spatially overlap. They would be separated. They had one camera each, so one camera would record one, the other would record the other one. Each one had a microphone and a cardboard where we would put the scripts. And first, we would record audio only in English and then audio and video in the native language. So once we got the recordings, that's where the fun started. We had to do the Wizard of Oz simulation of the live translated session and then process the audio. So I manually aligned all the segments so that we align the translation over the original speech, and then we apply a delay. We used an approximately 3-second delay. It was a bit longer for Kannada, so that we simulate the time the interpreter is processing in order to deliver the translated speech. And then once we have those channels with the correct alignment, that's where we apply the spatial conditions that we want to test. So before that, for the native speech, it was always the same. Native speech channels, they were docked 18 dBs, so it was lower than the translated speech, and they were spatialized. So the original is spatialized. You can hear the left speaker from the left, the right speaker from the right. And then for the translated speech, which is what we want to test in this user study, we had 4 conditions. They are listed here, but I will go one by one in this visual graphic. So suppose this is how it looks. We have the listener in headphones, and they're looking at the screen, and they have 2 participants who would be speaking between each other in native language. Crosses are native speech location, and circles translated speech. So the baseline is the diotic case, which is 2 ears, non-spatial. The original speech is always spatial, but the translated speech is exactly in the head of the listener. It's non-spatial at all. It's just in your head, as we generally listen to things in headphones. The second option is the United Nations translation style, which is just 1 ear, either left or right. We would randomize this, but all the translated speech comes from 1 ear, although the original is still spatialized. Third option is the spatial condition, where we place the translation exactly at this location of the original. So both channels are spatialized. And then spatial with reverb is the one that we take the original, compare the original, and we push it forward with some reverb. So we add some room effect to simulate that the original speech is a bit further away. Okay, so once we process everything, we start with the design of the experiment. We decided to run a within subjects experiment with 4 audio conditions. And we had 4 scripts in 4 languages that ended up with 16 recordings, and then we applied 4 audio conditions in each recording, 64 scripted live translation sessions. But 64 for each participant, that would be extremely overwhelming. So we decided to get each participant to listen to 8 recordings. It would be 2 languages per participant, and they would hear to both sessions, mixed gender and same gender. And we had these 4 groups: people who would listen to Greek and Kannada, Greek and Chinese, Ukrainian Kannada, and Ukrainian Chinese in 2 phases. Now I would like to show you a few samples how the audio recordings look like. So I don't think you'll hear the differences here, but if you listen to the recording later, you would. So monaural case.
Hey Nina, how's the rollout of the new productivity feature going?
Hey, pretty smoothly so far. We have completed internal testing and started the pilot with the marketing team.
That's great. Any early feedback?
Actually, yes, they love the interface, but here's the twist. Someone discovered it also tracks break times.
Let's listen to the spatial example.
Hey Nina, how's the rollout of the new productivity feature going?
Hey, pretty smoothly so far. We have completed internal testing and started the pilot with the marketing team.
That's great. Any early feedback?
So what we would hear in the headphones is that there's a slight separation between both speakers. You would hear one speaker from the right, one speaker from the left. Okay. And here's the same gender case with the other two conditions. So one is diotic, the 2 ears, non-spatial.
Hey Reese, did you understand what Maria meant in her message about the video files?
Sort of. She said we need to label them, but I wasn't totally sure which ones she meant.
I think she was talking about the ones from our safari trip last week.
Oh, the ones where we saw the lions.
And then the fourth one is spatial with reverb, room effect.
Hey Reese, did you understand what Maria meant in her message about the video files?
Sort of. She said we need to label them, but I wasn't totally sure which ones she meant.
I think she was talking about the ones from our safari trip last week.
Oh, the ones where we saw the lions.
Okay. You can listen to them later. Okay, so the study itself was designed to be remote, approximately 30 minutes long, and each participant participated with consent, obviously, and had a compensation of $25 for their time. And it was structured with 2 phases, so each phase had one language, and each phase had 4 listening sessions. Each listening session had a particular script and a particular condition, which we would not disclose at any time. So they would be listening sequentially 4 audio conditions without knowing which one is which. And then they would respond to a questionnaire, a quiz, and then some Likert scale questions about their satisfaction and cognitive load, NASA-TLX type of questions. And at the very end, they would have a recap question, sort of like an open interview where they could type with natural text some responses. And that would happen for each phase, so for each language, which is also randomized. To estimate how many people we needed for the experiment, we did a Monte Carlo simulation where we fitted a model that predicts the comprehension score using the spatial conditions as independent variables. And we did a likelihood ratio test with the full model versus a null model with one intercept, so basic mean. And what we found out is that after running 500 simulations with each sample size, we found out that for achieving a statistical power of 90%, we needed more than 45 participants. So we went ahead and we recruited 47. And the key eligibility criteria were first to be fluent in English in order to understand the translation, and second is to have no to little knowledge of Greek or Slavic languages, Ukrainian included, and then no to little knowledge of Chinese or Dravidian languages, Kannada included. And the screening was made via an onboarding survey, which had this ILR scale, you can see it here, where they self-assess how do they feel, are they proficient in a specific language or not. And if they said that they are not proficient at all or had some very elementary basic proficiency, then they would be eligible. Otherwise, they were not. So after running all those onboarding surveys and recruiting 47 participants, we ended up with this stats. We tried to have all the groups more or less balanced. So we ended up with 24 males, 23 females. Since each person was listening to 2 languages, we also had we have more numbers in the language section, and they're also more or less balanced. And then the age group was more skewed towards 25, 26, 35. So one important thing is that we had this sequential order of conditions, and that could bias the results. And we actually checked it, and it was actually biasing the results. The session order was a random effect that we wanted to exclude from our results, from our modeling. So this is a plot which shows the performance in comprehension across all the 8 sessions. So 4 for one language, 4 for the other language. And we can see that it's always increasing, and then at the 4th session is decreasing. It's sort of repeating the pattern itself as a wave. And this is something that we didn't want to have in the results, because it's the audio condition is a fixed effect that we want to study, but this listening session, which might influence the comprehension, is a random effect that we want to exclude. The explanation behind why it's fluctuating as a wave, it can be that the first session they have shock. They start listening and they're shocked by the setup. They get adapted to listening to the specific language, to those specific participants. And then session 2, there's a learning effect. They improve. 3rd, they also learn even more. It's improving. But then by the 4th session, they're already tired because we're doing the same thing 4 times over. So that's why we can see this small decrease. So we, as a conclusion, we included the session order in our model as a random effect to control this. Also, as a test, we fitted a random forest classifier to predict the comprehension score using those variables, and we see that the feature contribution of session order is the highest, even after it goes even after the audio condition. So it definitely has a lot of effect. So once we remove it, then the first and most descriptive variable is the audio condition, which is the one we want to test. And then voice timbre, you'll see that we also got a lot of responses on that. It's the least one, but still has some effects. We also checked, just a sanity check, what was the comprehension score across all the different scripts. And we can see that even though they were all 1 minute long, some of them had more success than others. But since participants listened to all of them, that shouldn't be an issue. And then across all the languages, the comprehension was more or less the same, so it was stable. There were no differences across different languages. Now let's start with the actual results. So first, we modeled the correct answer response based on the audio condition and fixing the session order as a random effect. And what we found out is that comprehension with any spatial condition, spatial with reverb or without, increased 80% in odds of correct response versus non-spatial. And then if we check comprehension with the spatial condition with no reverberation versus diotic, non-spatial with 2 ears, the odds of correct response with spatial is twice as higher than diotic. Checking between non-spatial conditions, 2 ears versus 1 ear, we can see that the odds of monaural, they decrease a bit. So the performance with monaural is slightly worse. Then we analyzed the comprehension for each specific question. Remember, we had a time-based question, role-based question. So for the action or theme question, the chance of correct response for spatial was 90% roughly, and for the 2-ear non-spatial, 75 roughly. And the pairwise comparison estimate between both conditions was marginally significant. For the dialogue attribution question, here's the distribution of the correct responses. So with spatial, it's the highest again, 76, and monaural 1 ear was 63. And the pairwise comparison between those, each of those didn't show any significance, but it did show significance in the role or identity question. Here, spatial is 63%, diotic is 40, and when we checked the comparison between spatial and diotic, it was definitely significant with a p-value of 0.02. And we can ask.
Could you remind us what was the diotic case?
Oh, diotic is 2 ears, so it's non-spatial. It's like hearing, it's all in your head. Spatial is translation and original, the same location. Diotic is.
Diotic means the same signal on both heads.
Yes.
So it's inside to your head.
Yes.
Okay.
Yes. And then spatial monaural. Monaural is just 1 ear, also very significant. Finally, for temporal detail, spatial gave a 75% chance of correct response, while diotic 62, monaural 56. And the comparison between spatial and non-spatial was also statistically significant. After checking the comprehension, which is the most quantitative objective measure, we moved to the Likert scale scores, which are more subjective. And we also did some statistical testing, so we found out that spatial has been found significantly easier to understand than non-spatial. Spatial also was clearer in distinguishing speakers than non-spatial and felt more immersive. Although no significant differences were found for overall satisfaction and distraction, statistically speaking, the preference was over spatial, but it was not sufficient for a statistical difference. This result can be explained that the spatialization, it enhances the cognitive and perceptual clarity, but maybe the overall holistic experience doesn't really change because we're still hearing true voices at the same time, which can be very overwhelming. And it's a very odd condition to be. It's not natural to be in such a conversation. In terms of load, we used NASA-TLX scores, and we got a significant result that spatial improves the performance confidence. So users, when they were responding the quiz in the spatial condition, they felt more confident about their responses. However, in terms of temporal mental demand effort, there was no statistical significant differences.
So how do you measure the workload?
NASA-TLX score, so it's from 1 to 7 Likert scale.
Subjective?
Subjective, yes. Just as a curiosity, we also checked what is the effect of the voice timbre. So remember that for dialect attribution, the spatial condition didn't really give a significant difference statistically, but when we checked the different conditions in terms of mixed gender or same gender, that was clear. The chance of correct response with mixed gender was 85%, while with same gender was close to 51%. Definitely, it's a factor to distinguish the speakers. And now we finished with the quantitative results. We did a thematic analysis with the open-ended responses from the final section, the recap section, where participants would just report their feelings, their thoughts about what just has happened. So the first theme from all those responses is about the impact of the audio configuration on comprehension. And many people felt that hearing the translation with both ears was helping to understand over just 1 ear. So hearing from 2 ears, it was easier to follow the conversation because it's natural to hear with 2 ears. It was clearer. With 1 ear configuration, this often was not perceived great in terms of comprehension because people would find this setup confusing because they are seeing a person talking from the right, but they're hearing it from the left. And especially when quick switches happened, so 2 people switching, having a conversation, switching who's talking, that was the most confusing part. And obviously, seeing the quantitative results, we could expect this also in the thematic analysis that spatial audio improves comprehension, which was mentioned by many participants in the study. because they could align the spatial cues with the visual cues and help separating the streams. Second theme is about focus and cognitive load. So here, surprisingly, I said earlier that one ear condition was not helping with comprehension. However, some participants said that it was helping with focusing on the conversation. Even though they wouldn't keep track of what was said, they could keep track of who was saying with the one ear configuration. But the issue was with the turn-taking during the conversation. If there was a lot of exchange between the speakers, they would lose track. But it was just one speaker talking for a long time, then the monaural helped focusing on what that speaker was saying. And then, in contrast, there is another subset of participants who said, no, even the one ear configuration was not helping with focus because it felt unnatural and it was, they could easily lose track because of the exchanges between participants. As you can see, one person said that that was jarring. And then again, spatial audio reduces effort, mentioned by many speakers again, because it was more easier to identify who's speaking at each time and following the turn taking. Another recurrent comment is that the original audio volume strongly influences focus. When they perceived that the original audio was loud, and that was described as distracting or confusing. But the perception of being loud or not really depends on how involved you are with the conversation. Maybe if you want to know that person, if you want to know how they sound, maybe you want to hear that language, the original language. But if you don't really care and you're just listening to this conversation, maybe you just completely want to remove the sound. So there was some variance in this response. Some people even requested to completely remove the original audio. But in that case, you would not really build rapport with the person behind. Speaker 3 is about speaker differentiation and attribution, mapping the sound to the person. And many people agreed that both ears and spatial audio improve differentiation because, again, it was easier to see where is it coming from. And timbre is another big differentiation factor. Since the timbre, the voice quality is different between the participants in the mixed gender session, it was easier to know who was talking, even if you lost track of the conversation. Some people even asked to artificially change the timbre in the same gender condition. Fourth theme is about interference and overlapping, also a recurrent topic, which is unfortunately unavoidable in live translation setup because we need to overlay a translation over an original speech, which some people were led to miss details because of this overlap. They would just focus at some microsecond to the original speech and they would lose track of what was said in the translation. But that happened not only in people who could get some specific words, but it also happened in people who would not know the language at all, the original language. Its presence just reduced the clarity of the translated speech. There's a comment that said, even though I don't understand the original language, I felt distracted to hear two voices at the same time. And a final theme is about temporal alignment and synchronization. The lag between the original and the translation really disrupted the focus of the participants. And this gets worse with languages that have a longer delay. But this is unfortunately something that we can really prevent in a live translation scenario because the translator has to listen to at least a small segment before start translating. And the mismatch between the video and the audio, that's also something that comes from the previous comment. It's a direct consequence that there is no synchronization between the lip movements of the original speech with the translated speech. And some people, they resorted to closing their eyes or looking away because they were really distracted by this non-synchronization between video and audio. So as a synthesis across all the themes, we can say that the general feeling was that there was higher satisfaction when the speaker identity, who is speaking, was clear, the translation was easy to focus on, so all the conditions that help improving the focus, they were better, and then listening felt natural, which was mostly in the two-ear case. And based on that, the preferences clustered mostly around spatial setups and setups that would reduce the original audio. That was a recurrent request. Overall, positive factors: both ears, spatial audio, distinct voices, lower original audio, small lag. And negative factors: one ear setup, when you don't have clear turn taking, high original volume, and overlapping speech, which is unfortunately unavoidable. And as conclusions, back to our hypothesis, we have been able to successfully validate all of them. Spatial audio indeed is statistically significant in improving comprehension in a multilingual teleconferencing setup. Spatial audio also lowers cognitive load according to our TLX measure and the thematic analysis. Spatial audio also enhances the ease, clarity, and feeling of immersion in the meeting. And finally, spatial audio also helps with a better speaker attribution, mapping the speech to a particular face on the screen. And just as a note, final note, we can say that there are some factors in this multilingual setup that we can control. There are others that we can't control. The ones that we can control is the obvious delay between different languages and the overlapping condition, which is it's unavoidable in live translation. But there are things that we can control, like rendering. And we just need to find what is the best way, what is the best configuration to tune those controls that we can change. And then another thing that we can also analyze is the interaction between those different effects. What are the interactions between the things we can control and the things we can't control? And that sometimes really depends on the situation. So as I mentioned before, maybe if you're emotionally involved with the participants in the meeting, you really want to hear their voice slightly, so you want the original to be a bit louder. But in a case where you don't really need this emotional rapport with the participant, maybe you want it even lower, just to follow the conversation and comprehend the key points. So for future work, we leave all the study for the interactions. Do we want a video off or on? How does this change? Here, our condition was clearly passive. The listener was listening to a conversation between people and the listener was not interacting. What about if the listener also interacts with speaker? It's another setup that might have some differences in the conditions we studied. But that's for future work. So as of now, thank you for listening. And I want to thank all our participants and confederates who made this study possible.
Questions?
Yeah. First of all, thank you for a very nice presentation and a talk. So other than the spatial clues, I was one of the listening participants. So I also used the clue of the temporal information. So especially when there are two people of the same gender talking, when I can see the video and the first person starts talking and then the first translation appears in the video, I also start associating without the spatial clues, okay, this voice belongs to this person. So did you imagine like an experiment where you can initially hide who starts talking? I saw that in your future work you were considering video on, video off. So when I let's say when I start listening to a meeting from the middle of the meeting, or so there, especially now there were scenarios where the other person was talking in their original language and then the translation of the previous person was appearing on the audio. So because I already associated the sounds with the person and everything using the temporal clues, so it was easy. So in this kind of a scenario where I enter the meeting in the middle, there the spatial clues would actually help me quite a lot when I start the meeting in the middle and then I hear the translated speech from the right of my ear and then I associate it. So did you consider such an experiment to see if, or are you considering such an experiment in the future?
Potentially, because in this case we just use video only. We didn't have the option to disable it. But this heuristic, I saw it in the thematic analysis. Maybe it was you. But a counter question, would you use this heuristic more in the mixed or in the same gender scenario, or in both? To rely on who started first?
Ideally in the same gender scenario, because I hope I can distinguish the vocals of different genders. Yeah, ideally in the same gender scenario, and especially in a scenario where I don't know both the participants, I have no clue how their voice sounds like. Yeah.
I wonder what would happen if you join the meeting at the middle of the call and you don't have the video and you don't know who really started first.
Yeah, exactly. That's what I was thinking. And such a scenario actually spatially rendering people's voice to different sides might help.
Yeah, that's a interesting point. Yes, but we didn't include it in this experiment.
Thanks.
So the original sound was rendered to the headphones using HRTFs or just left and right?
HRTFs.
So they have a distinct position, the original. And the same thing for the case and spatial audio for the translators.
Exactly the same azimuth.
So that was the question. What if you spatially separate even the translated voice? Because humans use the direction to separate, and maybe if you put a little bit broader the translated voice, they will be able easier to suppress the original sound, or because they complain that it is interfering with their perception, or maybe just lower it and make it further away.
So we didn't use a different azimuth for translation and original, but the condition that would be closer to that is the one that we added reverb. We added a room effect to the original speech, so you could feel that it's a bit farther away. And even some people thought that the level changed, but the level did not change. We just changed the how diffuse was the sound.
Maybe to that reverberant sound to adjust a 15 degrees more off the direction to allow the listener brain to suppress the original sound and to listen to the translation.
I think that the challenge with these when you play with azimuth is that as soon as you add more than two.
Yes, definitely.
Yeah. Yeah.
There is a question in the chat. According to page 36, let's go to page 36.
Hong, you can maybe ask the question.
Yeah, so on that page, if you look at the 1 year result for comprehension, it is actually slightly better than diotic, and a tad better, not sure if it's that sick, compared to the reverb version. So I heard the comment says, the anecdotal comment said, it's good to hear from both ears to help you with perception. But this data shows, as long as they're separated, you don't have to have both ears to hear the content, which I agree for the rest of it, for direction and all that. It's inferior when you just have 1 ear. I just wanted to point out this is counter. Yeah.
That's a good comment, because the visuals can be a bit misleading, because the result I'm showing is the estimated marginal means. So we include the session order in the model. So this is the prediction of the mean without excluding the order. The results in the visual, they have the order, so it might have more fluctuation. So that's why you might see the monaural being higher. Although if we exclude the session order, the model gives a lower mean because of that, because it just subtracts this pattern from the data.
So after you subtracted, let's see, if you subtracted, yeah, let's say if you take away the first session, right? What does this graph look like after you take away the first session?
So this graph, it's an average across all sessions.
Right, right.
But the number I'm listing here is the prediction of the model. Is not the mean from the data, is the mean given by the model. And the model excludes the session order. So it should account for that. So all the extra points that people would give to the monaural case because it ended up, for example, in the third session, that would be excluded in this mean. So it's more like an unbiased mean with respect to the session order, while the graphic has this inherent bias included.
But how do I know how did that monaural did?
I guess what Hong was suggesting is if you, from the graphic, if you would remove just the first session,
Right, yeah.
which had the biggest impact, what would the graph look like? And I guess
Right.
what Rita is saying is that if you did that, the mixed model, mixed effects model would predict that monaural would be lower than spatial reverb.
I just didn't include the
Sure.
monaural, but
I was just wondering if you take out the first session, is it better? Is the monaural worse than the diotic?
Yeah, we can check that.
Mhm.
yeah, we can.
Yeah,
we
just
can check
curious,
that.
just curious, because it's contradicted that comment. And the other comment I wanted to make is the people ask about how to identify, and Teams doesn't have this highlight, this window when somebody is talking, so you kind of can see that. And that supposedly we're working on that feature is when the translator is going and the original speaker should get highlighted when the translation from the original speaker. So you know that helps you to know who's speaking to.
That was also a comment. One of the comments, people mentioned that they would like to see a visual cue on the screen whenever someone is talking.
Right. Yeah, in the real product, it does have that. It will have that with translator, but yeah, not. I think maybe not yet. I think they're still working on it.
I'm looking at that fatigue graph that you showed. And disclosure, I was also part of the recording session for this experiment, so I heard some of these sessions back to back. I'm wondering, so some of the conversations sounded very foreign to me, just because I don't happen to work in that space or not have interest in that space. I assume when someone is on a meeting call, they're interested or invested, or the theme of the conversation is something closer to them or of more interest to them. So I wonder if you would have seen the same fatigue effect or not if the topic of the conversation was something closer either to what you're working on or something, or even if the names were closer to your coworkers' names, maybe you would have a little bit that more engagement and you wouldn't have that fatigue.
Yeah, my intuition is that it would change. The perception would be that they would like to be more invested in the conversation. They might want to hear their voices more, because some people, they requested to completely remove it. But in terms of fatigue, maybe yes, but I still think that there will be some learning effect at the beginning.
Yeah, so to that point, maybe you could remove that some of the learning effect in the beginning, if they are people you know, a topic you understand, and you know what to expect. Like once you've been using this feature for a year, probably the first 5 minutes are not going to show this dip in the first session that we get here.
Maybe it will be flatter.
The first session effect, how I attributed it, because I also had to respond to some of these questions. After the first session, I was not expecting expecting that level of detail, to be asked about what time was the meeting. And I had that shock, I wasn't actually following that closely. So then instantly on the second session, I had to tune in. So I feel like the first effect is a little bit different, but I wasn't expecting expecting that I would be asked that level of detail for comprehension. Hence, I wasn't as tuned in. But over time, because a lot of us are in meetings for hours per day sometimes, right? So, and that effect of fatigue may not show as early if you're a little bit more
engaged.
Yeah, it's still interesting that you see the same dip in session 5, which is just this exact same thing but with different language, right? So at that point, by 5, I know what to expect, but now it's new
these
speakers.
are the one. Oh, interesting.
Yes,
Yeah,
it's
so now it's
first language.
It's just new
second
speakers,
language.
new language. So there's again an adaptation period where I don't know the voices, I don't understand the languages, and it's
Okay.
yeah. So it's a mix of both.
There was a person who mentioned that they had this issue because they were adapting to this new set of speakers, like new people, and the first session was adapting to these new voices compared to the previous section. And then there were some cases where people took a break for a few hours between the first language session, the second, which also could make this effect to be repeated.
So if you're designing this system for a real-life usage, what would be your recommendation? What is the best variant from all of those variants you explore? They have pluses and minuses, but what seems the best trade-off for a real-life system?
For this, from this study, it seems like using spatial helps. Using 2 ears is the preferred option, unless it's just a monologue. If it's a monologue, then 1 ear option might be better for some people, but generally 2 ears. Having a slider for volume for the background for the original voice, so that people can tune the most comfortable background level. And then related to visual cues, what Hong mentioned, having visual cues, some people also asked having captions. So having those options optional, and they can choose whichever condition makes the comprehension easier for each particular person, each particular session, because it's really dependent on how engaged they are with the speakers, how engaged they are with the theme. Are they interacting or are they just listening? And all that.
From the 2 spatial audio options, with moving the original voice further and without, which one you would say is more preferred by the users?
By the users was preferred without reverb.
Without reverb. So technically we can say that specialization without reverb and putting 18, maybe even 24 or 30 dB down of the original voice is something which seems most preferred according to your studies.
Without reverb was not significantly different between with and without. So the trend was towards no reverb, but it was not significantly statistically significant. Mm-hmm. So overall, I would say spatial. If we had to choose between 2, no significance, but the preference is for spatial, no reverb.
Okay. Thank you.
So, for how many participants do you expect spatial differentiation to still be useful? Like here is all for 2 participants where they get clear left and right separation. How many people can you add in like a group call and still have this be useful?
That's a good question. I think it can change pretty wildly if we include even more people, because for example, if we have speakers on the first row and second row and third row, then the perception of the elevation is not as strong as the perception of horizontal change. So I can't really say. That's something that should be studied as well.
There's actually some paper. Hannah knows, right? It's, I think 15 degrees is what the paper said would be helpful to lower the masking. Horizontal 15 degrees. Yeah, vertical is very hard.
But so yeah, so for 4 people plus minus 30, you would still get a pretty decent.
Mm-hmm.
But it depends, if you're on a laptop is one thing, if you're in your office in the front of a large screen, you get that 15 degrees vertical difference between the two rows.
Is it between visual or?
No, acoustic, like that's right, yeah.
By the way,
yeah.
Teams does have that capability to adjust the relative volume today. So if you play with that, you can adjust the relative volume of the original speech versus the new speech. I think that it's a little tricky to think about how initially I was kind of hesitant about this spatial audio in the original location, because let's say if this person is having a monologue and he's talking for a long time and his translation is constantly coming from the same direction. Now, is it better that way, or is it better, I'm still thinking about the mono kind of case, right? If I have a lecture and this person is talking all the time, there's no back and forth. Is it better I have the translation constantly coming from the single person, or should I shift that image and put it in one ear? Is it better? I assume it's better to completely separate them, but this test, it's faster switching. I think it wouldn't evaluate that scenario.
That was polarized in the responses because some people, a small subset of people said they were focusing better with the monaural condition, but they were a bit distracted when there were interactions between the speakers. So
Yes.
since this is a different scenario where we have just a lecture room, that would have another effect. And I think that in that case, we might have even more people preferring monaural. But with a few people on the call, spatial seems to be...
I think back and forth, yeah. Maybe it should be, the conclusion should be, it depends on the type of meeting, right? If it's a completely a lecture and or person talks for minutes at a time, and maybe it is better to have more separation.
Any more questions? I have a quick one. Did any of the participants in any of the comments request for the original to be louder for some reason? Or did they even did they comment in any way on the original, like, oh, it was the same voice, the translation of the original was the same, or it helps me, I don't know.
Oh, about the level, no one asked for a higher level. But the second, a few people noted that the translated voice is, they thought it was an AI translation, and they thought, wow, this is a pretty good AI translation. But why does the translation have this accent? Is it possible to remove the accent? So that was one of the comments.
What, to have an accent of the original language?
Slight accent, yes, because it's the same, it's the native speakers speaking in English. And even though they are proficient, they might have some,
Always.
Yeah, it's actually a feature in the current AI translator. I don't know how they did that. It actually has it is AI, it's generated by the signature of that person. And it actually has a slightly tint of accent, not too heavy. It was very cute in a way, because I didn't know that was possible. Yeah, they did it that way.
Yeah, when I tested Spanish, my voice in the Teams Spanish translation was Latin Spanish. So it was not Spanish from Spain, it was from Latin America. And it was funny to hear myself.
Accent, even Google Maps, you can choose which accent you want to hear in your information. So it's been out there for a while, I think.
Yeah.
At least for me, I found it difficult because one is, of course, there is the background speech in the original language, and then there is the translated speech. Because some of the speakers were quite new to me, I was also struggling a bit to understand their English accent, because English is neither my first language and not their first language. So yeah, other than struggling with the background audio in some other language, I also had to put a bit more effort to initially get the accent of the other person in English. So once you're used to a particular person, then you get accustomed to their English accent, and then you start understanding it.
And that's totally reflected in the session order curve, the adaptation from the first session.
All right, last call for questions. If not,
second call for...
Thank you.